In this lesson, we're going to look at some more patterns and identities that we can get from the unit circle. So I'm going to draw the unit circle on the axes to the right. And we're going to start over again because that did not start out so great. Hopefully this is better. Harder than it looks on my tablet. Okay, so now on the axes, draw an angle with its terminal side in any quadrant. So I'm just going to draw it first quadrant. It works wherever. And we're going to do what we've done a few times before. We're going to draw a triangle using this angle similar to previous lessons. So we're going to draw, here's our triangle. We're going to label the point where it intersects the unit circle as XY. And we are going to label the sides of the triangle X here, Y here, and 1 over here. So here is my angle that I've chosen. And we're going to be talking about the sine, cosine, tangent, cosecant, secant, and cotangent of that angle. Now, I don't know if it's come up in class yet, but I do want to mention it in this video. Sometimes people are like, why do you use theta? Like, why not just X or Y? Well, when we're on the coordinate plane, X and Y are already taken as values of points, so theta is kind of like a different variable, so it doesn't get confused with the X's and the Y values. So we already know this, we've done it on the unit circle. When we use this picture, we can see that the sine of the angle is equal to Y over 1, which is the Y value on the unit circle. The cosine of the angle we know is X over 1, which is the X value on the unit circle. And then tangent we know is Y over X. And just to file away for the future, this word tangent is used in a couple of spots, especially in calculus. If you look at the values for tangent, Y over X, that actually is equivalent to, as long as we're starting from the origin, what we do for our slope formula, right? And really, we usually write change in Y over change in X. But if we started from the origin, that is the slope. So the slope of the angle is actually also the tangent. If I talk about the slope of this ray that I drew, is the same as the tangent value. Now for the other ones, we haven't talked about these yet in terms of the unit circle. If the sine of theta is the Y value on this unit circle, then the cosecant of theta is 1 over Y, right? Because we flip that. If the secant of theta is, or if the cosine of theta is X, the secant of theta is 1 over X, and the cotangent of theta is the reciprocal of tangent of theta, so that is X over Y. So what this means, and we'll see, is that anytime we have a point on the unit circle that we're saying is the point where an angle intersects, from the X and the Y value, I know all 6 trig functions without even really needing a triangle. Now, often we draw triangles just so we can make sure that we're, clear on it and it's new, but the point on the unit circle is sufficient to find all 6 trig functions. These are identities. Any equations we do that are always true. So as long as we know that point's on the unit circle, this is always true. These are 6 always true statements. On a test, you might say, draw a picture of the unit circle and show Y. The cosecant of theta is 1 over Y. So knowing how to draw this picture and then find the ratios from it is in itself important even before we start to use it. So moving down the page, this says an angle in standard position intersects the unit circle at the point radical 5 over 3, negative 2/3. And we're going to find the values of cosine theta and cosecant theta in the following ways. So first off, we're going to draw a picture. And this is similar to what we did in the last lesson, except we didn't necessarily know that the point was on the unit circle. Yeah, that one's off center, but we get the idea. So radical 5 over 3, negative 2/3. So I am positive negative. So I'm here. And we said that the X value, so here's our point out here. So this is radical 5 over 3 here. And this is negative 2/3 here. And we know if it's the unit circle, this is a 1. So from this picture, here's my angle. Really, here's my angle, but we're going to use the reference angle in the triangle over here. So we're going to figure out the cosine of theta. Okay, so theta is actually out here, but this angle, I really shouldn't label that with theta. Technically, theta is the outside angle, but this angle, which I'm now just going to show with a dot, and we'll go with a green dot. Okay, that's the angle we're using in the triangle. So cosine is equal to adjacent over hypotenuse. So we have radical 5 over 3 over 1. Something divided by 1 is just itself. So the cosine of theta is equal to radical 5 over 3. The other value we're finding is cosecant of theta. We know that that is going to be the reciprocal of sine. Sine we know is opposite over hypotenuse. Here we're going to do hypotenuse over opposite. So I have 1 over negative 2/3. And then I'm going to take that down here and keep change flipped. So 1 times negative 3/2. So this just equals negative 3/2. That is my cosecant of theta. Now, we can draw a picture. It's still highly recommended you draw a picture, but using the identities from part 1, we can actually do this straight from the point. So the first thing that was asked for was the cosine of theta. We know that on the unit circle, because that is true of this problem, that the cosine of theta is just the x. And if we look at our answer we found drawing a picture, that is true. The cosecant of theta, because sine of theta is the y on the unit circle, cosecant of theta is 1 over y. So if I just use 1 over the y value, and we already did that keep change flip, we know that's going to be negative 3/2. So we can see that the point on the unit circle makes that triangle unnecessary to figure out those answers. Looking at a couple of other applications on the next page. Okay, actually not. We're going to look at another identity on the next page. We're going to actually do more practice with that in the next lesson using those points on the unit circle. Today is just an intro of it. So looking at this one, it says now we're going to learn another identity, so another true statement that comes from the unit circle. So I'm going to draw that circle. This one has a side bump, but maybe a little more centered than my last one. So now we are going to draw an angle with its terminal side in any quadrant. So maybe I'm going to draw this one over here. So here's our angle, but we're using this triangle to talk about the trig functions. So that reference triangle. Now we're going to label the sides of the triangle. So we have 1. I'm still labeling this x. I know it's going in the negative direction, but it is the x value, which happens to be negative, is the number I'll use. So just like all the other times, when we work with this angle, sine is y over 1, which is y, and cosine is x over 1, which is x. So now we're going to write, and this goes back to the first lesson, what is the equation of the unit circle? So we know that equation is x squared plus y squared equals 1. That's our parent circle, the unit circle with the center at 0, 0, radius 1. So if this statement is true, that's a true statement that x squared plus y squared equals 1, and we substitute the appropriate trig functions for x and y in the equation of the unit circle, we can take the x out, right? And we can plug in cosine of theta. So I'm going to write that here. And we can take the y out, and we can plug in sine of theta. So it also leads to, and is true, that cosine, I meant to write first, let me just erase that. The cosine of theta squared plus the sine of theta squared has to equal 1. So I've just plugged the cosine in for x and the sine in for y. Now, a couple different things about how we write this. This is called the Pythagorean Identity. Comes from the equation of the circle, Pythagorean theorem from the triangle. That's why it has that name. When we write it, we typically write sine first, not cosine. Now, also, when we write this, and this is just notation, when we want to say the sine of theta squared, it can be a little tricky. We don't want to write the parentheses because we try to cut stuff out in math. So we actually take the squared and put it here. So instead of writing sine of theta squared, we write sine squared theta. Then it's really clear that the whole trig function is squared when we see that, when we're used to the notation, and not just the angle squared. So we write the sine first, and then we're going to do the same thing with cosine. So cosine squared theta, and that equals 1. So in the next video, we're going to look at a couple ways that we use that. But this is the Pythagorean identity, a statement that is always true for all angles.